Hello everyone, welcome back to another video. Now today we're talking about another element in linear graphs and linear relationships, and this is the idea of the y-intercept. Now, just for a little definition of just what this actually means, the y-intercept just means where the line passes through on the y-axis. So where line passes through on y-axis. So I draw any line here. Well, say I did something, let's do this a little nicer, something like this line here. Well, my y-intercept is just going to be this point here, where along the y my graph passes through. So this thing is my y-int for short, but we're looking at the y-intercept here. Now, why is this important? Well, not all graphs pass through the same value of y. Now, for an infinite number of linear relationships where we can have a bunch of different y-intercepts, a bunch of different points where our graph passes through the y-axis. Now, let's compare one from a previous video. Now, I was a little cheeky here because we're looking at the gradient and I put an equation of y equals 2x in that, well, the gradient's 2 because for each step in x, we go up 2 steps in the y. But there's one thing I actually left out and I wanted to leave it for this video. And that was that, well, this line actually passes through the point y equals 1, or the point 0, 1. 0 on the x-axis, 1 on the y-axis. Now, that's curious because this line is, say, different to this one here. This passed through 0. This one also passed through 0. But not every line has to pass through this origin, this 0, 0 point. We can actually pass through anywhere on the y and anywhere in the x as well, but we'll talk about that a little bit later. Now, looking at this, our graph here, we are going to look at it and we're going to first lay out what the gradient is. We're going to figure out what the gradient is because we've talked about how that's important for just telling us general things about a graph. But we're going to identify what the y-intercept is, and then I'm going to go into talking about the general formula of lines and how we can translate everything that's happening on my page into an actual nice equation, which tells us about it. So, looking at this here, well, let's first find the gradient. Now, in the last video, we talked about how the gradient was just the rise, how far up the graph goes. And this can be between any 2 points because the gradient's constant. But here we have that this is 3 units. And from, say, we'll look at from this point up to this point. It goes 3 units up and 3 units across. So the gradient m equals 3 on top of 3. And we can kind of see that here. If we go up 1 unit in the x, we go up 1 unit in the y. 1 unit in the x, 1 unit in the y. 1, 1. So we're kind of always ascending 1 step each. So our gradient here, in other words, that'll just be 1. Now our y-intercept, which in some textbooks they call it B, in some textbooks they call it C for whatever reason. But our y-intercept, well, that is 3 here. We pass through the y-axis at the y-coordinate of 3. So here, whoops, wrong pen. See here, my y-intercept equals 3. Now, just an interesting point here. No matter how I drew kind of any type of line, right? Whether my line looked like this, whether my line looked like this or this or this or this, each of the y-intercepts on all of these lines, well, let's think about what the x value is. What is the x coordinate at, say, this y-intercept, or this y-intercept, or this one, or this one? Well, my x coordinate is always 0 when we get the line intercepting our axis, our y-axis. So if we trace x along, let me actually rub out all these extra lines so it doesn't get too confusing for you. But looking at my original line that I drew, well, what's x here? X is -4, and it goes up to -3, -2, -1, and right at the point 0 here, that is horizontally, so in the horizontal direction, where I get my line passing through my y-axis. So we can say actually that the y-intercept occurs when x equals 0. And that's a pretty important point here. Now, I'm going to, just looking at this graph here, I'm going to now show you the general formula of a line. So the general formula, or just essentially how it's laid out, we write this as y equals m, our gradient x, plus c, our y-intercept. Now, let's look at the graph we actually had here. Now, by taking sort of each point, say, along this graph, well, we're going to, first of all, plug our values here that we got into our formula, and we're going to verify that visually on our graph. So here, for our line, well, y, the general formula is y equals our gradient m, which is 1x, plus my y-intercept of 3. Now, 1 in front of the x, that's like saying 1 times x, and any number times 1 just equals that number. And since x can be any number, we can just write this as y equals x plus 3. If only I could shift this across. That's okay. I'll rewrite it. So our formula, or our equation of the line here, is y equals x plus 3. Now, we found this just by plugging in things I've told you, right? Now, just to get you thinking about how this all works, well, let's start looking at a couple of points here. Now, first of all, our gradient tells us that, well, when x goes up by 1, y goes up by 1, because our gradient is 1 here. Our gradient is 1. So that's great. But we're also told that, well, my y-coordinate from the equation of my line is always going to be 3 more than my x-coordinate. So if I take any point along x, well, y should be 3 more than that. So let's test this. Well, let's look at this point here. Let's look at this, right? My x here is -2. So judging by our equation, for this point, my line, based on the equation, my y-coordinate at that point should be 3 more than x. Now, 3 more than -2 is 1. And that is exactly where, along our vertical path, my y is. Take this point as well. Say at x equals 1. Well, y should be 3 more than 1. And lo and behold, our graph passes through, our graph, when x is 1, when x is +1, my y equals 4 here. So now we're adding another layer to our linear relationships. We're saying, okay, we know what the gradient does, and we've shown that the gradient is kind of constant throughout this line that I've drawn here. But we're just adding another level to this now. Well, we're saying that, okay, we have my line y equals x, right? But +3 tells us that this now passes through a point that is not the origin. That is not the point 0, 0 in the middle here. It's passing through another point. And we know now that that's our y-intercept. We're passing through that. But now we also know that each of these points, that means that anywhere along my graph, my y value will satisfy something that is 3 more than whatever x value we see on our graph. And we see that all the way through. We saw this at -2 because my y value was 1. At -1, my y value is going to be 2. At 0, my y value is going to be 3. So y here is always 3 more than x. Now, we covered a lot in this video. So just to kind of backtrack, the y-intercept, the definition of that is just the point along the y-axis when the line passes through it. So where the line passes through on the y-axis. And we also came up with a general formula for our equation for any line, any linear relationship. This is just that y equals the gradient here multiplied by x. So that tells us how the y changes with x, as well as the y-intercept, which is what y is when x equals 0. Hopefully you can see that here. When x equals 0, that's when we get the y-intercept. So that just tells us, well, where does the line pass through? Where on y, what the y is when x equals 0, or in other words, where it passes through the y-axis. And that tells us everything we need to know about our graphs, about our linear relationships. We have a gradient, we have a y-intercept. And this type of form of our linear equation is what we call the intercept gradient formula, because it tells us two pretty key parts. It tells us what our gradient is and what our intercept is. So we're going to deal with this idea a lot more in the coming videos, and I'm going to introduce a few more important concepts. So I'll see you there, and we'll keep exploring intercepts as well as the gradient and this formula we have come up with for all lines, for all linear relationships. I'll see you there.